Yes. Uh, is there any doubt in last class? Is there any doubt in the last class? Doubt is na? Is it? Good. Then like. Guys, quick. No doubt. Shall we continue? Doubt ಯಾವಾಗ ಬರುತ್ತೆ ಹೇಳಿ? When you will get doubt? Huh? When you have completely understood. Doubt will come only when you try to understand. When you completely understood, like Chetan, right? Yeah, then you will not get doubt. Right. To say everybody that don't write instructions, because we will follow one standard format. Because I have seen like one or two guys have already attempted it to write. ಯಾರೋ ಒಂದಿಬ್ರು ಬರ್ದಿದ್ದೀರಿ, ನೀವು ಬರ್ದಿದ್ದೀರಿನಾ? ನೀವಿಬ್ರು ಯಾರೋ ಬರ್ದಿದ್ದೀರಿ? ಅದನ್ನೇ ಕೇಳು. Attempted to write is ಅರ್ಧ only. The thing is, you have to write this instruction immediately after the 5 programs that we have written for data transfer. Okay? Please note that don't write record because I am saying it, write it. If you are doing that, you can come like I cannot write a record, please excuse me. I will excuse anyway if it does not carry marks. Is it clear? Record is a systematic document for you to understand the subject. Because it is not an individual topic that you study and then like next topic is not connected to this. Dependent. No, not like that. If you have to write a program, then you should know what is a Rom structure. Right? So what is the instruction? What instruction does? How it does affect the PSW? You should know all this connected. These are all topics are connected. That is why we need a record. Take it from me, it will not carry any marks. Right, please tell me, sir, I cannot write, please excuse me, I will definitely excuse you. If you write with a negligency and then you torture me, that like I have to correct it. It's a double punishment that I am receiving in the process of asking you to learn something. I don't want to do that. If you are interested, write it properly. If you don't write it properly, please tell me once. And please understand also like why asking you to write. You are not the kids that I should say like you have to write the tables from 2 to 10 times. Of no use. Copy paste from there to here and like of no use. Okay? Please write with the intention of self-learning. And this will become a very good document for you to refer. That is the intention. Okay? Before writing write the classification of instruction that we have given in the last class. Instructions are 255 and they are classified into based on the addressing modes and the operation. Based on addressing modes, there are 4 types. 5 types of addressing modes are there. Immediate, register addressing mode, direct addressing mode, indirect, indexed. 5 types are there. Data transfer, Boolean, branch instruction, and subroutine. In your textbook, some of the textbooks, branch and subroutine they will combine. So there will be 5 again. What we have done is 6. We have separated branch and subroutine because we believe like different. No, we not believe it is going to happen. There is a different way of execution of branch instruction and subroutine instruction. That we will see when we discuss. When I do a subroutine and jump, the program controller PC, program counter value will change. It is one common similarity. There are other dissimilarities we will discuss when we are discussing that part of the instructions. Is it clear? So first is that you have to write that thing. Next is this. You should write, of course, please follow this standard. Then like instruction, then description for an instruction, then classification, then number of bytes. This should be the way in which you write an instruction details. Example. I will write one example for it. The instruction that I am considering is add a comma r0. Add a comma r0. What is the opcode for this? R0. Huh? 28. Is an opcode for it. Description. Guys, here. How do you write a description? What it does? You should understand what is this. Description is it adds these two and puts back the value to A. If you cannot write in this way, then you explain in the English. If you cannot write, some instructions are there where in which you cannot write like this. There you have to explain it. Then like classification, what classification is this? What type of addressing mode? Addressing mode. What is the addressing mode? What is the addressing mode that it follows? It is a register addressing mode, arithmetic operation. Byte, for this the byte depends on the opcode with if it is the data size. For example, if a comma hash 28 is there or hash 38 is there, then their instruction carries 2 bytes. Instruction is 2 bytes. If it is only add a comma r0, instruction is 1 byte. These details are also there in textbook at the last. Then oscillator cycles. As it is a single instruction, single byte instruction, it will take 12 cycles or 1 machine cycle. Or you can write, 12 is enough. You understand 12, right? 12 cycle is 1 machine cycle, you understand that. So 12 is enough. Like this is one example, you have to write like this 255 instruction. So in this lab, we'll write it is scattered. It is not at one place. Move instruction of codes are not in sequence. Some have 38, some has 92, something it is scattered around. So what do we expect? This to be completed after internals. Will not hurry bari. This 255 instruction, this full details to be completed after internals. After internals, which are Wednesday. So after that week, not immediately after that, in that week, after that week, you can show me this in the record. Is it clear? So don't indulge in writing the record right now. Study for the internals. Start study for the internals. Okay? Is it clear? This please understand. You should not give me the reason that like they told, he told, Digant told, Ganesh told, Digant told, it will not work. Right? Everybody has told. I am telling it is a common instruction to all. Is it clear? This girl, Divya Guruswamy. Divya has written record very neatly. Right? If you want to refer her record. Okay? Right. Done. Is it clear? Guys, clear? So we will see this after internals in your record. Okay? Right. What we do now is the one which we have done in the first class. Okay, listen. We have written one small program. Then we say like this is the opcodes for it and this is how it is arranged in the memory, ROM memory. We'll discuss on the same thing again. We'll write one small program. What is the small program that we'll write? ORG00H. Please, all of you write this. Move A comma hash 04H. Move R7. Is it visible? Is this visible? Hash 03H. Add A comma R7. This is a program. Oh, we'll add that S jump here. Okay, we'll add that S jump here because it is there in your lab manual. So we'll try to explain that also. What is this program? In front with you. What is this program? It just, how do you write comments for it? Guys, what is the program? I just want to add the content of A and content of R7. See the result in A. That's all. Simple program. How do you write a comment for this? When I asked you to write a comment, most of you have tried writing in the sentence. It is not exactly required. See what it does. It is A equal to 4H. 4H or 0x04, it has the same meaning. 4 hexadecimal or 0x has the same meaning. Is it clear? Right. Next, in here, R7, 03H. Here, A equal to 4 plus 3, 7H. Or you can write A plus R, 7 and then like 7H. This does. This figure, see here. You cannot write this in the statement like this. So you have to use a sentence. Here, S jump here. Please check. Now please check the instruction format that we have discussed. There has to be label, mnemonics and opcodes. Opcode or opcodes. This and this are in brackets. That is why this does not have a label. Label is an optional thing. Memory and explain that. Right? But this statement is jump. S jump is short jump. There are 3 types of jumps. Short jump, long jump and absolute jump. In this instruction, the S jump stands for 8-bit of 8-bit address location. That means 2 raised to 8. 256 bytes forward. Or 128 bytes forward, 127 bytes backward. You are understanding? What is the meaning of Kamath? What you are talking? No high jump. Oh, no high jump. It is only long jump and short jump. Right. It is just saying that when I say jump, what happens is your program counter, it will take this instruction and execute. Take this instruction and execute. It will take this instruction and execute. If you say jump here and give it here, after this, your program counter will hold the value of this instruction address. This instruction address, right now, it is a description like this. You are writing a program counter with this value. What is this value? Address of this instruction. Right? Just changing a program counter. When it is S jump, you can change it only in the 2 values. 0, 0 to FF, 256 bytes, 256 values. To only 2 bytes, 8 bits. I'm saying 2 bytes, 1 byte, 8 bit. It's an absolute jump. You have 11 bits at 2 raised to 11. 2 raised to 11 is how much? 102420, 2 KB. So you can change the value for 2 KB, this thing. Then like when it is a long jump, you can take the value for 16 bits, 2 raised to 16, that is 4 kilobits. Huh? So 16, right? 2 raised to 12 is how much? 2 raised to 12 is how much? 4K? 64? Yeah. Yes. So what you can remember is S jump 8 bit, A jump 11 bits, L jump 16 bits. This 8 bit address, 11 bit address, 16 bit address. Is it clear? That means if your program is huge, long program, then if you give S jump, it will not work. Because it can change the PC value only in the last 8 bits. PC 16 bit value, only last 8 bit it will change. If you want to take from change the PC from 000010, then you should use long jump. If you just want to change it from 0000 to 10, only these 2 bits are varying, then you should use short jump. Is it clear? Again the discussion will come, there we'll discuss. This is again just to say like what is this happening, what is the types of jumps we have, right? Right. This we have to explain it under branch instructions, right? So, right, what we do next, we'll write here that description, we'll write it here only here. Say infinite loop, right? Now what happens when you write this program? You know what is the procedure to write a program in Keel? When you open a Keel project, new project, right? Then like you save it, it will create one program project, this thing, under that source code. This will be ready. What you have to do next? Oh, before that you have to select the CPU from the CPU database. That is where you are selecting the cross compiler. Okay. Then you are going to, then it will ask you whether to add up a startup code or not a startup code. Then you should say no, because startup codes are required for hardware experiments. For a simulation, you don't require a startup code. What this startup code does, we'll discuss when we are doing that. Then like that project is ready, then you should go to file, new file, create a new file, type your program like this, then save the file with .asm or .a51. Under BMS is a project name, your 4th A will be the file name, 4a.asm or 4a.a51. You should save the file like that. Okay. Then attach a file to project, build the project, then you should check the errors. If the errors are 00, then you will go for debug. To debug, what you can see is this program goes and sits in the ROM. What is the ROM size? What is the ROM size? 4 kilobyte internal ROM size. And we are not discussing on the external. External is maximum is 64 KB. And this 4 kilobytes only specific to our example 89C51 RD2 or whatever the IC that is in textbook. If you go to market and ask, there are different size of ROMs available for 8051. Whichever the ROM is there in the 80 bits are only 16. So 2:16 is 64 kilobytes. Using microcontroller, you can address only 64 kilobytes of memory. You cannot extend more than that. There are techniques, but they are slightly complicated. Clear? Right. Now, we'll see what happens in the ROM structure. This is a ROM. ROM it goes from 000 memory location to last memory location is 0xFFF. Correct? 0x002 00 this thing. Now in this case it is 0x001. What is the content of this ROM location? Sorry. Second here is 0x001. What is there in this memory? What is there in this memory? Opcode for this first instruction, move a #04. What is the instruction opcode for this? Move a immediate, quickly. We will do 74. 74 is here. 74 is here. What it says? Move A, immediate value. What is the immediate value? 4. So that will be in the next instruction. No, I have written 74 here. 7404. Now what is this value? Move R7 comma immediate. What is the opcode for this? Move R7 comma immediate. It will be 7F. 7F next 03. 0x002. 0x003. Next. Once it is 03 is done, add A comma R7. 2F. Right? 2F has a standard opcode because both these registers are known to the architecture. This is not known. It can change. That is why this has to be stored here. 2F means add the content of A and add the content of R7. Store the result in A. Is it clear? What is the next statement? This is done S jump. What is the address for S jump or the opcode for S jump? 0x005. You know? No, I'm not getting it. Added value. This is why it is stored here. It is stored in RAM. What we are doing here is we are converting your program from assembly to the opcodes. Once it is executed, value of this addition will get stored in the RAM because A is in the RAM. Remember, A is in the RAM. What is the address? SFR. No, it is 0E0. In the SFR RAM location, 0E0 is A. In there will be A value, 7 will be stored. That is the difference. During execution, the compiled code is this. During execution, it uses that SFR or the RAM memory. Is it clear? Right. Next, what is the, after 2F, what is the S jump? 80. 006. What will be here? Who will tell? To tell, I will give one prize. Chocolate code. Help. What will be here? 0x006. 80. Next. 80. What is the address? 0x 6 5. Here there will be 5. 8-bit address. You are understanding this? You are understanding this? This is S jump. This is address of S jump. Address for S jump. Where it has to jump? It has to jump to 5. It will jump here. What is there? S jump. Then like where it has to jump? 5. It will jump here. You are understanding? It will rotate here only. Is it clear? Now what is 2F? Add, right? What is 3 is on data. What is 7F? What is 7F? Okay, move R7 comma hash data. This is data. What is this? This is data again. Here it is move A comma hash data. This is very, very important program. Theoretically, this is the first time doing. Bharat. Continuous, sir. Continuous again. It is sequential. 100% sequential. Until and unless you give jump here and there, it will going in sequence. For words is 00H. In this program, no. show me that. ಏನು ಬರಲ್ಲ, ಇಲ್ ಬಿ ದೇರ್. ಇದು 7 ನೀ ಎಲ್ಲಿಂದ ಕೊಡ್ತಾ ಇದ್ದೀಯ? ಪ್ರೋಗ್ರಾಮ್ ಇಂದಾನೆ ಕೊಡ್ತಾ ಇದೆಯಲ್ಲ. ಓಕೆ, why? If it is from ORG 00H, it should start from the 00H. Let's see. But this will like this. Guys, any doubt in this? Any doubt in this? Okay, right? So, this is a ROM memory location. We'll write here as a ROM memory location. This is what will be in the ROM. Move A, comma. No, move A, comma R0. A is also known to the architecture. R0 is also known. It is only 1. If it is unknown, like some number, I don't know, this can be 4 or 28 or 39, random. So it will be stored here. If it is move A, comma R0, content of A is also known, R0 is also known, 1 byte. Right, guys? Now, yes, so it is empty location. You can say this is a ROM. If you write small b here, it is bits. If you write capital B, it is bytes. Please be clear, because 4 kilobytes is 4 into 1024 into 8. 4 into 1024 into 8. 4, 1024 kilo. Byte is 8. If you write small b, 8 will go off. 4 into 1024. Clear? Right. So, that is the ROM address. This is the ROM address. These are the ROM addresses. This is the ROM structure, the opcode changes. No. Does it say it for 2 bytes? Please check. Instruction add A, comma R7. Please check. In byte 1. Huh? Add opcode. Wrong opcode. Yeah, this is how it is. Now it is taking 2 bytes. Move A, comma 4 is taking 2 bytes. 74 and 04. This is only one instruction. Guys, this is taking 2 bytes. It is one instruction actually. In here it is one instruction. This is instruction related to that instruction, data is here. For add A, comma R7, the simple understanding is this. A is also known to the architecture. Known. It has to take only one. If it is unknown, it has to take that unknown into account. For one byte for instruction, for unknown it is 1 or 2 bytes. Any doubt? Any doubt? Clear, clear. This is very important program. This visualization should come into your picture, the understanding. Whatever you write, this is only for your understanding. Processor will understand like this. This is a program for a processor. Is it clear? Is this clear? Shall we go to the next one? Right. Right. What is the one more important thing in this is this, guys. ORG and end. This does not have any opcode. This does not have any opcode. If I write ORG here 40H, what happens? The whole program will shift from 0x040. From there it will go. Originate the program from 00H. Please write comment for this also. Originate program from 00H. For end the program. For end, write end the program. Now, after this you write one side heading. Assembler directives. assembler directives. ORZ, ORZ, comma, end, END, comma, DB, capital D, capital B, DB, comma, EQU, E capital, Q capital, U capital, EQU, equal, EQU, R, assembler directives, are some examples for assembler directives, are some examples for assembler directives, which directs or it directs. Some example for assembler directives. It directs assembler to do some operation, and hence does not carry, and hence does not carry it directs. It is there as it directs, right? It only directs. Make it as only. It only directs. That means ORZ and end or DB or equal to, these have the meaning for assemblers, does not have any meaning for the microcontroller. Is it clear? Here to here, the change is, this is an assembly code to this opcode, a software assembler. When I was a student, I told you, like, we didn't have this skill. We used to write a program in Notepad, then call this assembler in the DOS. Then there was a turbo assembler and macro assembler. There are two types of assemblers which are widely used throughout the world. They are called as turbo C and this is C is there, right? Similar to that, like turbo assembler was there and macro assembler was there. We used to call that assembler software, then like attach this file to that. Then it used to assemble and give the generate and dot. Is it clear? Now you don't understand it because it is inbuilt into the key. But without assembler, your code will not be converted from this mnemonics code to the opcodes. It will not be converted. It is the job of an assembler. Is it clear? Right. So these are all the assembler directives have meaning to only the assembler software to tell interaction between this code and the software. They have no meaning in here. This meaning goes for controller. Clear with this? Is it clear? It is very similar to your hash include. Filer that include this file also. Right? That is, the hash include is called as what? Compiler directive? Huh? Processor directive. Preprocessor directive. It is just to direct a compiler or a software, yeah, do this job. They do not have any meaning in the opcode. Is it clear? Now in this, you know ORG, you know AND. What you don't know is EQU and DB. We'll quickly discuss on those two things. What is this EQU does is, SCS, EQU, count equal to EQU, then you can write move A comma hash COUNT. You're getting this? That's all. Example. Below that you write COUNT count equal to EQU 30H. Then you can use it as a, it is like int A equal to 30. Same concept. Variable name and the data. Is it clear? Please write this as an example. This is enough to understand what is the EQU does. Next one. DB. DB is define byte. Write DB and define byte below there. DB is define byte. What it does is, please look here. It does it as like this. My data DB BMS. My data, DB, BMS. Each and everything that you do in the 8051 microcontroller has to be 8-bit. If it is 16-bit, it is your responsibility to break that into 8-bit and handle it. The programmer's responsibility. Because there is no register except DPTR and PC, there is no register which... So, and you cannot add the DPTR and PC. You have to bring that data to one of the registers in the RAM, R0 to R7 or A or B register, then you should do the addition. So the breaking of 16-bit value into two 8-bit values, it is your responsibility. This is a program that we are do in an arithmetic operation, addition of two 16-bit numbers. Right? So you should handle this 8-bit separately, this 8-bit separately. Then like you have to give the value in total. Okay? So define byte is, if I write like this, let's assume this as ORG40H. What happens is in the memory location 40H, this is ROM. In the memory, guys listen very carefully, I am not going to repeat it again. In the ROM location 40H, your ASCII value of B is stored, then M is stored. Then a kind of doing define bytes is very useful when you do the LCD display. LCD display, you can go this, you can fetch this as BMS, Bangalore. So your comma will be next and the Bangalore B will be next. A, O, L, O, same, it will go on next. Correct, right? So this my data will hold that value now. Now how do you access that? To access this you have only one instruction. Move C, A comma at A plus PC or DPTR. Indexed addressing mode. We have given two examples. Those are the only instruction through which you can access this. It is like an array. DPTR address is 40H. Plus A value, whatever the A value will give, it will go and access that byte. Here the ASCII equivalent of the B, M, S will be stored. Is it clear? Please write this example. How much time we have? 10 minutes, 5 minutes. Guys, done? Right. Quickly we'll write 1 point or 2 points for the addressing modes and wind up this addressing. Clear with this? Right. Go to the next one. Addressing modes. Mention addressing modes and in that immediate addressing modes. Whenever it is an immediate addressing mode, in bracket you should write that font symbol, hash symbol. Below that, you know the examples for this, right? Yeah, this is only the peculiar immediate data. This is the best example for your immediate data movement. Move A comma hash count. We are not knowing this. Otherwise, move A comma hash 35. Move DPTR comma hash 4000, 1000. We did this in the lab. We are very associated with that, right? So, immediate. Please write one sentence there. Source operand is constant. Source operand is constant and destination operand will be a memory location. Will be a memory location or a register. Register also has a memory location in that manner. Will be a memory location or address. Now what is the meaning of source operand and destination operand here? See here, this is the source operand, this is the destination operand. Always that it happens like this, it's never like this. There are some controllers and assemblers where in which it will be reversed. So you should write move 40 hash 40h comma a. It depends on the assembler and the controller structure. Now for all that 8051, it is like this. This is a source operand. This is a destination operand. Is it clear? Destination operand can be a location or address. Sorry, also has a location address. Clear? Right? And the source operand is constant. 4, 5, 10, it has a constant number. That is why it is constant. Right? Next one. The register addressing mode. Register addressing mode. Register addressing mode. Source and destination registers. Source and destination register size. Source and destination register size should match. Source and destination register size should match. Source and destination register size should match. Means move A comma R7 will work. This will work. Why? Because R7 is 8-bit, A is 8-bit. Correct? You cannot write move A comma DPTR. Not possible. Correct, right? Not possible. It is not. DPTR comma A is also not possible. 8-bit to 16-bit. It will not understand which 8-bit. Higher 8-bit or lower 8-bit. Yeah, we'll come to that. How do we solve this? We should do like this. Move DPH comma A or DPL comma A. This and this should be of same size. That is what is the meaning of this statement. Is it clear? Write an example. Example 1. Example 1. Example 2. For this you write a comment as invalid. Invalid. This is not a valid statement. Or it will throw an error. Register size mismatch. Register size mismatch. It will throw an error. Is it clear? This is the next example. Example 3. There is one thing which is not allowed. Where is that? Where is that? One second, guys. Yeah. Below this you write move R0 comma R7. Move R0 comma R7. Quickly check in your instruction sheet, is it there? Both source register, is it there? Quickly check. This is invalid. Then how do you move the content of R7 to R0? Move R7 to A and then A to R0. This is the only way. This is invalid. Please write this. Done. But there is a method to do this, another method. One method is as you told. One method is as you told. For this moment, we have a solution in the direct addressing mode. Go to next, direct addressing mode. These are particular points or specification in the addressing mode that you can use or you cannot use. We are discussing on that. Go to direct addressing mode. Direct addressing mode, the example 56H comma A, what it happens? Location in where? Goes in RAM. Clear? It is while execution, your ROM is not touched. I have told you 100 times, it is a very sacred memory. When it is such, we'll discuss at the end of the semester. Write, not touch. You have no authority, no permission to write to ROM. You have no permission to write to ROM while execution. It is always the RAM. So content of A will go to the 56th location in the RAM. Please write this comment. This is direct addressing mode because we have the address directly here. Similarly, the other way, you can write A, comma, such will come to A. Clear with this? There is one more very interesting thing in here. That is 7, 2. Move 7, 2. What is the previous instruction that we have written? Heli, let's go. Time up. What is R1? Guys, listen. RAM memory location. Harshit. RAM memory location, address second, content is copied to RAM memory location address 7. That is nothing but move R7, comma R2. You are understanding this? This was not possible. If you write R7 and R2, it is not possible in the register addressing mode. But in the direct addressing mode, it is possible. One, the answer that you told is right. Content of move R2 to A and then A to R7. That is what you told. This is also possible. This is a valid instruction in direct addressing mode. Please mention this is similar to this. Or like write the statement. Write a statement. Move the content of RAM memory location 2. RAM memory location 2. 2 is 0x02. 2. TTO2. RAM memory location 0x07. Move the content of RAM memory location 0x02 to 0x RAM memory location 0x07. Clear with this? Right.